Hello, everyone. Welcome to the second part of our probability lessons. And this video will be focusing on independent and dependent events. All right, let's take a look at important concepts that we need to recall. All right, so the first thing that we need to take note of is both independent and dependent events probability problems use the conjunction and, which also indicates that the calculation involves the mathematical operation multiplication. All right, so these are two things. Okay, so I already highlighted it. So independent and dependent events will use the conjunction and to calculate the probability of both dependent and independent, you need to apply multiplication. All right, so the next thing that you need to take note of is independent events. So there are keywords that you need to look out for in order for you to identify that the given probability question is an example of independent event. Okay, so the keywords are with replacement, returns, or returned. So these words will actually help you identify straight away what formula you need to apply. Different formula for independent event, which is this one. So probability of A and B equals probability of A times the probability of B. So A and B here represent events. And if you have already watched the videos I uploaded previously about sets, so this symbol right here means intersection. And relating it to what I mentioned earlier, which is the conjunction. So this also a symbol for and. So you can say probability of A and B or probability of A intersection B. So that's the one. So that is the formula for independent events. All right, so the last thing that you need to take note of is the keywords that are normally used for dependent events. So you have to look out for these clues, all right? So keywords are without replacement or not returned. Okay, so onset of the question, if you see either of them, definitely this question is about probability of dependent events. Like what I mentioned earlier, there is going to be a separate formula for dependent events, and the formula is here. We have probability of A and B equals probability of A times the probability of B given A. All right, so maybe you're questioning what this part is, right? So it's actually based on what I mentioned earlier. So remember the keywords without replacement. So basically one thing is taken and it's not returned. So that actually affects the probability calculation for the next event, right? Since here, event A happened, definitely the probability for the second event happening will be affected by the first event that already occurred. Okay, so later when we answer example, definitely you'll be able to understand the effect of the things that are not returned or replaced. Without further ado, let's take a look at the first example. So for example 1, you roll 2 fair number cubes. Each cube is numbered 1 to 6. What is the probability that the first cube will show a 5 and the other cube will show a 4? All right, so like what I mentioned earlier, so you have the keyword there, which is and, right? So first of all, conjunction and, definitely it's going to give you right away the concept that, oh, this is multiplying probabilities. There are two events mentioned here. So the first one, so the first cube will show a 5. That's your event A. And the second event, which is the other cube, will show a 4. And also, after reading the question, you need to be able to identify first if it's independent or dependent by looking for the keywords. Okay? Because after identifying if it's independent or dependent, definitely you know which formula to use. All right? So going back to the question, so the second event is the other cube will show a 4. Okay, so remember, you rolled 2 fair number cubes. These are 2 cubes, so you have cube A and cube B. All right, so the first cube will show a 5 and the second cube will show a 4. So basically they are independent of each other, right? For cube A will definitely not affect, right, whatever is going to appear on cube B. All right, so to calculate the probability of this, so we learned that probability of A and B is equal to probability of A times probability of B. And then we just simply identify the probability of A first. So probability of A and B equals probability of A. So event A will show a 5. How many 5s do we have on a number cube? So there's only one 5. Remember, each cube is numbered from 1 to 6, okay? And that cube, that first cube, has one face that is numbered 5. So there's only one 5 there, right? So we write 1 divided by the total number is 6 because cube has 6 faces, and that's for event A, times event B on the other cube. So there's only one side that has number 4. So basically the probability for event B is also 1 divided by 6. And from here, we just need to multiply 1 over 6 times 1 over 6 is 1 over 36. And that is the answer. All right, what do you think of this question? Let me know by leaving a comment below. So let's take a look at the second example. You are playing a game that uses a deck of 20 cards numbered 1 till 20. The first 4 cards you draw are numbered 3, 8, 11, and 19. You do not return them to the deck. Calculate the probability of drawing the next card that is numbered 15. All right, so first we need to identify the key information from the question. Okay, so we were told that you already picked 4 cards numbered 3, 8, 11, and 19. So 4 cards have been removed from the deck of 20 cards. Okay, and you are picking the next card, which is actually the 5th card, right? So that means we've already removed 4 from the deck. And take a look at this. So keyword, do not return. Not returned, not replaced, definitely the probability of the next event will be affected by the previous events that already occurred. And which part of the calculation is affected? The part of the calculation that will be affected is the total number of possible results or possible outcomes, because you are now picking the next card here, but all 4 cards have already been picked and not returned, right? So basically the denominator of the fraction will be, it's not gonna be 20 anymore, right? Because 4 cards have been removed. So probability that the 5th card, okay, so the 5th card is 15. Since 4 cards have been removed already and not replaced or returned, basically the denominator here will be 20 minus 4 cards. And for the numerator, there's only 1 card in the deck that is numbered 15. So that's gonna be 1. And we need to simplify that. So it's going to be 1 divided by 20 minus 4 is 16. Therefore, the probability of picking the next card that is numbered 15 is 1 over 16. All right, so for your challenge question, get ready with your pen and paper and answer this. So to those who are not familiar with the deck of cards, so I attached here a photo. And the question that you need to answer is, in a standard deck of cards, what is the probability of drawing a diamond followed by a heart, then another diamond, without returning the previous cards? All right, so if you have the answer to this question, remember to leave a comment below. And if you think that this video is insightful, please don't forget to like, subscribe, and hit the bell icon so you never miss out a video. Once again, this is Mr. H, and thank you very much for watching, and I'll see you in the next one.